it's going to say error. It's going good. Hi everybody, this video is for my Algebra 1 students. This is a continuation of lesson 9.5, so this is lesson 9.5 part 2. We're going to be doing examples 4 and 5 on page 391, and if we have time we'll even get to example 6. We are going to be learning today about two theorems. I don't think they named them in the text, but what's called the conjugate theorem and the difference of two squares theorem. Before you get all worked up about big names and vocabulary, it's not that hard. Excuse me, they give you these two quantities in example 3, I think it is. No, it's example 4. It says you have a plus b times a minus b. Anytime we have two quantities multiplied together, we're going to use the FOIL method. So I'm going to multiply a times a squared. A times negative b, can't forget that negative, and I get negative ab. The inner terms, b times a gives me positive ab. And the last terms, positive b times negative b, and that'll give me negative b squared. When we combine these, the two middle terms, positive AB and negative AB, will equal 0. The word they use is called eliminate. They don't cancel, they eliminate. So positive AB minus AB, they're gone. And I'm left with A squared minus B squared. All right, that's interesting. Let's go on to the next one. It has x minus 4 times x plus 4. Do the FOIL method. First, x times x is x squared. Outer, x times 4 gives me 4x. Inner, negative 4 times x gives me negative 4x. And last, negative 4 times positive 4 gives me negative 16. These two middle terms eliminate, and I'm left with x squared minus 16. Watching for patterns. Let's go ahead and do the last one. We're going to multiply 3x times 3x, our first term. That gives me 3x squared. Our outer terms, 3x times negative 7y. 3 times negative 7 is negative 21, and we have to have the x and the y. Our inner terms, 7y times 3x, that'll give me positive 21xy, and then our last terms, 7y times negative 7. 7 times 7 is 49. Y times y is y squared. Positive times a negative is a negative. We combine where we can. Again, these middle terms, a positive 21xy and a negative 21xy, gives me 0, and they eliminate. I don't know if you've noticed this, but we have a pattern. First of all, a pattern in the problems. Each of them has a number plus another number, the same number minus the number. A plus B, A minus B. This one they switch the order, which doesn't matter. They still have x plus 4 times x minus 4. This one they have 3x plus 7y, 3x minus 7y. Those terms are called conjugates. Anytime you have a number plus a number, and then the same first number minus the second number, those are called conjugates. I could actually just use normal numbers. I could say 5 plus 2 and 5 minus 2. We'll come back to that in a second. Okay? But those are conjugates. We look at the pattern. The pattern, in this pattern, the middle terms always eliminate. They cancel each other out. Oh, I used the word cancel. I should have known. They eliminate each other, equals 0. And you're left with just the first term squared and the second term squared And every time, there's a minus between them. The first term here was a. Our first term in our answer is a squared. The second term was b. The second term in our answer was b squared. There's a minus between them. First term x squared. First term 4, or second term 4, second term 16 with a minus between them. 3x times 3x gives me, oh, nobody saw my, did anybody catch that mistake earlier? I should have been a 9. 9. Who do I owe candy? Throw it out. Okay. 9x squared minus 49y. 3x times 3x gives me 9x squared. 7y times 7y gives me 49y squared. There's a minus between them. Okay? There's also another theorem that we're not going to get into right now, but it says that anytime you have a number squared minus a number squared and they're asked to factor it, it will always factor into these conjugates. The square root of the first one plus the square root of the second one times the square root of the first one minus the square root of the second one. That's for another day. Okay? What would have happened if we'd had these two? 5 plus 2 times 5 minus 2. Well, we could do it the easy way. 5 plus 2 is 7. 5 minus 2 is 3. That gives me 21. Let's see if the conjugate theorem works with it. We'll do 5 times 5. Well, actually, let's not do that. The conjugate, that's the FOIL method. The conjugate theorem says it's going to be the first one squared minus the second one squared. 25 minus 4. That gives me 21, which we saw a moment ago is true. We're only at about 7 minutes. We're going to move on to example 6 on page 392. They're using this pattern to help you solve a fairly, not terrible multiplication problem, but it says multiply 87 times 93. That's a 7 there. Now you can sit here and set it up and go 87 times 93 and do your magic. Okay, do the math. We can do that. What they want you to realize, and I don't know how useful this is, but hey, it's still good information. This is 90 plus 3, and this is 90 minus 3. And they're multiplying them together. 90 minus 3 is 87. 90 plus 3 is 83. Those are conjugates. And I'm going to put them in different order. I hope that doesn't mess anybody up, confuse you. 90 plus 3 times 90 minus 3. I'll go ahead and write it. 93 times 87. In multiplication, just like in addition, order doesn't matter. 2 times 3 is the same as 3 times 2. Okay? So, if I use this conjugate theorem, my answer is going to be the first one squared. 90 times 90 minus my second one squared. I wrote it wrong. I wrote it wrong earlier too. Minus 3 squared. 90 squared, 9 times 9 is 81. And then you just have 2 zeros on the end of it. Minus 9. That will be 8,091. Let's check it over here. 3 times 7. 21. 3 times 8, 24, plus 2, 26. 9 times 7, 63. 9 times 8, 72, plus 6, 78. 1, 9, 0, 8, 0, 9, 1. The conjugate theorem even works for problems like this. The next one says do 72 squared. And they want you to use not the conjugates, but like the first thing. This is 70 plus 2 times 70 plus 2. When we have this is like those first examples we did in the last lesson, in the last video. This one, it'll be 70 squared. The last term will be 2 squared. The middle term will be 2 times 70 times that 2 there. 70 squared, well, what's 7 times 7? It's 49. We're going to have 2 zeros behind it. 2 times 2 times, well, 2 times 70 is 140, plus another 2 is 280, plus 4. 280 and 4, 4, 8, 11, 5,184. It's a useful pattern. Let's see if that's true. 72 times 72. 4, 14. 14, 50. 5184. Pattern works. We'll leave it at that. We're not going to do example 7, a cube, and we'll save that for a later date. Good luck, guys. Let me know if you have problems. Thanks. Bye.